Chapter 1, Exercise 1.119. A 67.2 gram sample of a gold and palladium alloy contains 2.86 times 10 to the power of 23 atoms. What's the mass percentage of the gold in the alloy? It's a comprehensive problem. We'll have to set up an equation. To solve the equation, we get the value of the mass percentage here. So we're going to use X to denote the mass percentage of the gold. And therefore, the mass percentage of palladium must be 1 minus X. Given these two expressions of mass percentage, we can have the expression of the mass of the gold and the mass of palladium. And for each element, we divide the mass by their molar mass respectively. We'll be able to get the number of moles, and the sum of the number of moles multiplied by the Avogadro constant will get this number of atoms. And therefore, we'll set up the equation here. First, let's say the percentage of gold is X. 67.2 times X. Alright, that's the mass of the gold. Now divided by the molar mass of gold, which is 196.97. Okay, you can get this from the periodic table. And then we have 67.2 times 1 minus X. We get the mass of palladium. So this part is the mass of palladium. And then divided by the molar mass of palladium, which is 106.42. Now we have the moles of gold, the moles of palladium. Together, we multiply this by Avogadro constant. And then we will have an equation. We solve this equation. We get X, and X is the mass percentage of the gold. Alright, let's look at this equation, and we'll solve for X. X is 0.539, so it's going to be 53.9%. What if you don't have access to Wolfram Alpha? You only have a calculator. Well, it is doable. It's just we need to break this equation into smaller, easier steps. So first step is this divided by this. Alright, so we're going to use this divided by this to get the total number of moles. So over here we're going to just do this. You can see we still have the same equation with a very small modification. Both sides divided by the Avogadro constant. And this part, the highlighted part, is the total number of moles of these two elements. Alright, and then we can, of course, look at the left hand side. On the left hand side, we'll have numbers, and we'll also have another number times X. So it's going to be a linear equation. Alright, after we simplify the left hand side, we will get a typical linear equation, which is a constant times X plus another constant. The result is this much, the number of moles over here. Alright, so it's this much. I think this is a bit less than 0.5. It's more than 0.4. Alright, so you can solve this linear equation by hand, or with a calculator. So again, you can just click the equal sign if you have access to the internet. You will get the same 53.9. What's the mass percentage of palladium? Well, it's going to be 1 minus this. That would be 46.1. Submit. We can double check. So get back to Wolfram Alpha. So this x is 0.539, and this 1 minus x is 1 minus 0.539. All right. And we're gonna just have the total number of moles multiplied by the Avogadro constant. We get 2.86 times 10 to the power of 23. This number matches with this number.